Welcome to Supply Chain Tech Podcast with Romney.
In this episode, we speak with Dr. Mikael Lind, a maritime informatics expert. Dr. Mikael is a strategic advisor and active contributor to the debate on open digital innovation, collaboration, business process management, and data sharing at the EU Digital Transport Logistics Forum, the World Economic Forum, and the UN CFACT, which is the United Nations Center for Trade, Facilitation, and Electronic Business. Dr. Mikael shares some of the challenges that the maritime logistics industry faces and how informatics can be a game changer for manufacturers, shippers, and freighters alike. Mikael, welcome to the Romney Supply Chain Tech Podcast. I have a very interesting topic today to cover with you. You are a specialist on maritime informatics and probably the only specialist of your kind today. I think you have the first book out on maritime informatics, also the only book which at least I found in the market that is really covering the subject in detail. Why this topic is of a lot of interest to me and a lot of people at Romney is that a lot of times the companies who actually come to us for visibility requirements are talking about how they can actually get control over their maritime shipping, right? Or maybe multimodal. And maritime informatics seemed very exciting to me as a topic because you are talking about basically digitizing the whole maritime information that is flowing across the vessels, the ports, and all the other custodians of data. And also how all of them collaborate together to actually work towards what you mentioned here is the United Nations 2030 Sustainable Development Agenda. So my first question to you, Mikael, would be, what is maritime informatics and what interested you in this topic?
So, first of all, as you are saying, there is a first book coming out now on maritime informatics, and maybe I should highlight that this is a very collaborative effort pursued by a multitude of co-authors that pay an interest to this. And it is actually 81 co-authors of the 23 chapters coming out from 20 nations, where it is very clear that this is a very strong interest from both academia or from the research sector and from the practitioner sector. And 47 out of those 81 authors, co-authors, are from the practitioners sector, and 34 is from more of the research sector. So first of all, informatics is something that has been existing for a long time in the field. And what we felt is that there are some unique characteristics in the maritime sector as a self-organizing ecosystem that needs that would have a great opportunity of being more glued together and then empowered by digitalization. So maritime informatics is especially utilizing the science of informatics to provide or become empowered by a very holistic view of how the different pieces are brought together in the end-to-end supply chain logistics. I think that is the first part that is important to mention. The other part, and that is what informatics is about, is really about collecting, storing, analyzing, and distributing data. And in that respect, as we see the whole supply chain being coming from a point of origin to a point of destination, and due to the fact that 90% of all the goods is transported by the means of maritime carriers, that would basically mean that we do have a strong interest in what is happening on board the ships, in ports, etc., like that. That could be empowered by digitalization.
So, Mikael, when it comes to all these data pieces that you talked about, how difficult is it today to actually capture all these pieces and integrate it together to get what you're talking about?
So, I think that we are coming to a situation now where everything is basically becoming connected. And it is becoming more and more simple. That's also a very important thing here. I think that the European Commission, the amount of zettabytes that is basically made access to is 80% coming out of data centers and 20% coming out of connected or IoT. And they are expecting that the relationship will be the opposite in 2025. That means that there will be a tremendous amount of data that you can actually utilize in your efforts in actually gaining situational awareness that spans beyond what you are in control of. And my feeling, and I especially like the IoT that is following the goods. I mean, so for example, the smart container, which would be an IoT device sitting on the container that is actually floating or going through a number of different transport means through ports or other transshipment hubs that could inform the cargo owner and the transport buyer of the status of the goods. So my belief is that it's not a question of any longer hiding from sharing the data, because the consumer of the data will anyhow get access to the data in some way. So, for example, if you just look at it, you take a ship master or a ship operator. Maybe they have historically been very peer-to-peer oriented in their data streaming or in the digital collaboration. But think about if there is a container on board the ship that now is digitally connected, that actually means that the GPS position and the movement can be tracked anyway, which means that there will be multiple sources of data for the same phenomena. And that will just drive quality and more situational awareness.
So, Mikael, you are talking about a complete connected maritime supply chain. When you talk about IoT devices, when you talk about all of this data coming together, what are the real hard problems that this is solving today? Could you give me some examples?
So, yes, I think that first of all, historically, the maritime supply chain has been held in a little bit of invisibility, and that has been very much about that ships cannot be really seen from the shore, and they have been moving over the ocean. Together with that, we have something called Mare Liberum, 1609, which means that the captain is the king of the sea. So a lot of the control has been left to the ones that is controlling the ship, so to say. But what we now see is that, first of all, there is a strong requirement from the transport industry that maritime transport should be much more connected. And that is the value that is extremely important for the shore-based actors to be able to plan its operations. You do want to have reduced stock levels. You want to have resource or capacity optimization on the shore end, which require a high degree of predictability of the transport operations independent of mode of transport. So at the end of the day, what you want to achieve basically is a high degree of capital productivity. That means that you would like to assure that, for example, for a shipping company, you want to have the ships being in movement as much as possible. Or if you're a port, you would like to assure that the container equipment or the cranes, etc., are utilized as much as possible. So therefore, you get a high return on investment on those issues. At the same time, we should also be aware of that a ship that is steaming through the water, the fuel consumption is exponential in relation to its speed. So, for example, a Super Panamax vessel, it steams 23 knots, fully loaded. It would consume 240 tons of fuel per 24 hour. If it steams 10 knots, it will consume only 40 tons. So having a ship coming to a port and sitting and waiting for being served is a really bad capital productivity measure, because you would consume more fuel, and it's also very bad for the environment. So what I see here is that enhanced digital connectivity would mean that you would be able to pursue more just-in-time operations or have a more integrated performance of the ecosystem of the supply chain.
I think it's a very interesting point that you touched upon, which is the integrated performance of the ecosystem of the supply chain, because in some of my conversation with export-import professionals at, say, food companies or pharma companies, especially when they are shipping cold chain, large containers of food products that are temperature sensitive, or large containers of vaccines that are temperature sensitive. The biggest question is, as a consumer, what level of maturity has maritime informatics reached? The common thing that I hear, Mikael, is that pretty much not much can happen once your vessel or your container is on the vessel, right? Because it's going to go from port to port. And the largest disruptions are really possible, or the risk is much higher when it is in its first mile or at the port or in the last mile journey. So when you talk about maritime informatics, how advanced is it today to actually bridge this data connectivity in the first and the last mile, and also within the port from a consumer perspective, or a shipper perspective for that matter?
So I fully agree here in many respects, because I mean, basically there's a lot of stories here that can be told, really. First of all, I mean, the first mile means that you need to assure that, let's say that we have a factory in one end and that is supposed to bring out the goods, and you're of course then dependent on the ship arrival that will come to a port, if you're talking about maritime, so that you are coordinating your operations in relation to that. What I see and hear a lot is that the port of tomorrow is establishing a lot of stocking possibilities for the manufacturer, so that basically when the ship comes, the goods are there being ready for being loaded onto the ship. And that is due to the fact that predictability sometimes is very hard for shipping companies. And facing it, if you think about container shipping, for example, they are normally on a port rotation schema between Asia and Europe, for example. And here a container ship would visit a number of different ports. And it is, if there's a delay in one port, which happens rather often, that is becoming accumulated for the next port, for the next port, for the next port. And then the catch-up is normally happening in the ocean leg, because that is a longer run to make. So that's one tendency that is happening. And in the last mile perspective, what I hear here now is that there's a strong emphasis on short sea shipping, where you would like to establish as many ports as possible that would be having a capability of taking the largest portion of the transport, and then you would come into a situation where the last mile is pursued on ground, because I mean, not everything is happening along the coasts, and that would also release the hinterland pressure, so to say, or the pressure on the road and railway systems. And here again, the connectivity and the information flowing from an arriving ship to another means of transport, of course, becomes important. And here, the future port will become a very important key player in making that communication to the other parties in the transport chain.
Yes, so definitely it is definitely a hard problem, because the data has to basically come together from the port to the first mile truck, to the vessel, to the last mile. Mikael, in this context, I actually worked on some of these systems like cargo IQ on the air freight side, which is essentially nothing but like an ERP that is actually bringing in all of these milestones onto the same platform. Is there something that exists like that when it comes to maritime shipping today, or is there something being built in that format?
So here the situation is very diversified, I think. There are some different type of how should I call it, platforms. I mean, in one thing that is talked a lot about is, of course, the regulated authority information coming via single window, and that is one platform environment, strongly regulated from IMO, what should be shared and not shared, and so that the different authority parties would have that information. You have phenomena such as port community systems, and you hear in the news that they are now starting to become more connected, etc. So, and there are a number of different more how should I call it, digital service providers that are enabling more of the connectivity between local data sharing communities, so to say. I would say at the moment that there is nothing existing as you would have, for example, for the IATA's one record model for the maritime sector. I think that the initiatives taken by, for example, Digital Container Shipping Association on standardization for their members is very promising. But I also believe strongly that we need to allow different local information sharing platforms that become connected more horizontally throughout the supply chain. And here we have initiatives such as Digital Transport Logistics Forum that is emphasizing a lot of efforts on a federated network of platforms in order to actually cater for that kind of connectivity.
Mikael, you talk about the importance of maritime informatics, especially in the post-COVID world, where you have actually mentioned that maritime informatics can flip the switch from efficiency to agility. How do you think this is possible today?
So, a very interesting question. And what I think here is that there is nothing so true that an initial plan will never hold, if I start that in that route. What I think will happen and is happening is that the maritime ecosystem is basically a complex adaptive system, which means that the different actors that are involved would need to adapt themselves in relation to other parties. And as the maritime sector is so self-organizing, and I doubt that we would have a control tower as we would maybe have in aviation, because otherwise the planes will fall down on the ground. That kind of logic does not count or is not applicable in the maritime sector. So basically, we need to find other models in order to handle the coordination. And we have been elaborating for the last 8 years, basically, on how can we promote models that support what we call collaborative alignment. Basically, if you share something on an ETA, or an initial ETA for the ship coming to the port, and then you share again and saying that I will be 3 hours delayed. And if you manage to share that in a common information sharing community, that would mean that the different actors would be able to adapt in relation to that. And historically, it has been power of sitting on the information, that's for sure. But now, as more and more devices are becoming connected, then people will anyway understand that things are not, or people will derive quality in the data, so to say. That means that you would, with more security, manage the adaptation and doing that continually. I think that some ports, for example, even though that they are informed very late, they are very, very good in adapting to the changes that are happening. So you might have a very big portion of ships coming late into the port, but you have very, very high precision anyway of serving the ships. And that is what you see in the large ports, because they have so much infrastructure that they can use in that kind of flexibility.
And Mikael, when you say that maritime informatics is also going to help realize several goals of the United Nations Sustainable Development Agenda of 2030, sorry. Can you talk a little bit about what some of these agenda points are and how maritime informatics is actually going to help realize that?
So, I mean, taking first of all, I mean, if we take the United Nations goal of poverty, I mean, and starvation, I mean, basically, what we just surfaced is that an aggregated view of supply chain visibility would enable a possibility to see how you can cope with many people that are dying from not having food today. For example, if you have a ship that is going to be delayed from one region in the world heading towards a developing country, maybe we can reorient that type of situation to actually save some of the 6,000 to 12,000 lives that is lost each day on starvation. So it's no longer a one-man show, so to say. Another issue would, of course, be that for example, if you can prioritize a COVID-19 container-related issue through the supply chain, giving that green light immediately, so that the medicines and the masks, etc., are coming to the people that really needs it. Then you would have, of course, energy efficiency, that's for sure, in the way that we talked about before. More just-in-time operations means less consumption of the Earth resources, both operational-wise and also investment-wise. I don't know, do you have any other examples that I should elaborate on?
No, Mikael, this is very interesting because I remember that when we were in talks with the United Nations World Food Program, they were talking about 97 million people that they actually fed in the year of 2019. And their whole goal was, the discussion was, what if you could actually feed 1% more of the population by bringing efficiency into the end-to-end supply chain? And what you're talking about in terms of the role of maritime informatics, which is where the bulk material actually comes in, any of these ports where the need for the secondary distribution begins. One disruption there, and then you could actually be waiting 30 or 60 days. So I totally understand where you're coming from, and I think the research that you're doing is phenomenal to actually achieving the sustainable development goal of the United Nations. Mikael, when you're talking about ocean insights and the data and collaboration, as an export-import manager of a company who is actually concerned about improving the bottom line, right, or ensuring on-time, in-full delivery, these ocean shipments are very, very long. They're like 30 days to sometimes even 90 days, right? How much of an impact does it actually have when it comes to improving your logistics or supply chain bottom lines or efficiencies as such today? Or is it more about just ensuring that there is no disruption and there is a reduction of risk? Because the biggest question would be, how can I apply all of this research and development into something that is practical and it's giving me monetary benefit if I was a for-profit manufacturer or shipper?
So I think the key here is predictability. And I think that the key is in the connection points. Captains normally, I would say, are pretty, that's a profession, to be steaming the ship and coming to a point of destination in time. I've several times talked to shipmasters, and I am basically asking them, were you in time? Of course I was in time. How about, was the port ready for serving you? No, not this time either. So there is something in the connection points that is extremely important for the importer exporter to be having information about. And from my end, I think that if we manage to get the transshipment hubs or those kind of phenomena more aligned, more coordinated to the episodic visiting actors, then I think that we would have a very much better and sustainable transport system. And having said that, that also means that I would foresee that a future port, independent on if it is a seaport, an airport, an inland or a dry port, etc., or a combi terminal, that they would not only in the future provide physical services, they would also provide a repertoire of digital services informing the clients of the transport system that way. And that would mean, on the other hand, that the importer and exporter would manage to also optimize warehouses, stock levels, etc., because they would be more informed. I think today, in order for an importer exporter to secure that they deliver good value to its end customers, they need to stock a number of different items that they are bringing out in order to cope with that. Unfortunately, a little bit too low predictability of what is happening in other parts of the supply chain.
And Mikael, as an import and export manager again, what are the baby steps that I could take to actually equip myself to embrace maritime informatics better?
I think that you as an importer and exporter should put pressure on the ones that you are actually utilizing in order to for them to share data to you about things that are of concerns for you. So again, data sharing along the supply chain is very important, and I think that there would be connectivity from data sharing environment to data sharing environment along the whole supply chain. And that pressure you should put on the ones that you would like to be informed, more informed.
So you're saying that by asking the information, you are going to actually help drive the change for everybody or all the actors in the chain of custody to collaborate better and collect better data through the supply chain.
So just to further comment on that, I think also that this is a very clear value chain. Importer exporters are engaging transport coordinators. Transport coordinators are engaging different type of carriers, and different types of transshipment hubs are being used. And if you push it from the highest level of and that is probably the end customer in some way, that they want to know more. I mean, just think about the nightmare. Yeah, your goods will be delivered sometime today or tomorrow, or the day after tomorrow. That is not okay any longer. So what you want to have is a higher predictability on that, and that should then go towards next company line and next company line and next company line, and then I think that there will be a change.
Michael, it's wonderful talking to you. A few closing words. I would request you to talk about the key takeaways from your book. As I mentioned in the beginning, I think this is the first book on maritime informatics that covers the entire spectrum. So what would you say are the top 3 takeaways that we could get by reading the book?
Okay, thanks a lot for that. I think that first of all, we are basically basing ourselves in the Maritime Informatics book on something that has been existing in the maritime sector for a long time. Everything started out of that the navigator required information. in order to navigate safely. That is a key thing to have decision power in your efforts. And the navigator then, or that became then something that actually needed to be a collaborative effort, because a lot of people saw different hazards in the water and so on. So having said that, what we have tried to do is to frame the maritime ecosystem as a self-organizing ecosystem, which would be empowered by digitalization. So that is the first one. The second takeaway is elaborating on how you can make and enable more smart decisions by digitalization in different ways, and we are looking up into different domains of smart decision making. For example, for the port, or for the port actor, for the shipping company, etc. And the third thing that is also being elaborated upon is how you can empower your decision base by more big data analytics, because there is more data coming out, and that you can actually do a lot of machine learning based on artificial intelligence, etc. So it's basically in 3 sections. This book, one is about the first one is about the more fundamentals. The second one is about data-driven decision making, and the third one is data analytics.
Michael, this is wonderful. I really appreciate your time to give us this little crash course on maritime informatics, its potential for the future, and how shippers and manufacturers can take baby steps to embrace it. Thank you so much for your time in putting this to us in very simple language, and I hope to get more insights from your book.
Thanks a lot.
Thank you, Mikael.
Hi, my name is Scott Mears, and I'm one of the hosts of the Supply Chain Tech podcast with Roby. On this podcast, we talk to supply chain heroes from around the world about everything, ranging from the disruptions related to supply chains, their personal experiences with tracking technologies, strategies to build resilience, and much, much more. We already have some recommended videos for you to the side of me, and if any of this sounds interesting to you, do subscribe to our YouTube channel and hit the bell icon so you don't miss another Roby video. I'll see you next time.